next time, tomorrow, I guess. For now, like I said, we're going to do these two. So I guess let's see what this IPv4 one is all about. So what is this question asking us to do?
An IP address is a numerical label assigned to each device, e.g., computer, printer, participating in a computer network that uses the Internet Protocol for communication. There are two versions of the Internet Protocol, and thus two versions of addresses. One of them is the IPv4 address. IPv4 addresses are represented in dot decimal notation, which consists of 4 decimal numbers, each ranging from 0 to 255, separated by dots, e.g., 172.16.254.1. Given a string, find out if it satisfies the IPv4 address naming rules.
Okay, my heart skipped a beat there, but it looks like just in time it came back to us. So hopefully everything's okay. And yeah, exactly. Thanks for noticing. The demonic description is the same as ever. Yeah, that one's not going to change. Anyway, okay, so IPv4. So you might be familiar with this. The other protocol, I guess, is IPv6, which came about a while back. But anyway, we don't need to get into like what these are all about so much. We don't need to get so much into the details of those. But what we do need to know is basically, you know, how we can check for these things. So essentially, what we want is four numbers separated by dots or periods. And basically, each of these numbers should range between 0 and 255. The inclusive range, I'm pretty sure. It can be 0 and it can be 255. Okay, so what we don't want is stuff like this, where we have a number that's bigger than 255. We don't want something like this, where there isn't a number there. We don't want that. We also don't want a situation where there's like more than 4 groups of these things. So if there are like more than 3 dots, then probably it's not going to work. Or if there are fewer than that. So there's like quite a few things to check here. So basically, let's come up with a game plan. So let's separate the parts, which are delimited by dots. And then after that, once each of those is separated, check that there are exactly 4 parts. And if it turns out there are 4 parts, check that each part is between 0 and 255. Inclusive. You know, just to be specific about it. And is that going to be good? Yeah, I think that should be good. Good. Okay, good. All right, so let's give this a try. So first of all, separating the parts, basically getting all these parts. I guess there are a few ways we could do this. You know, like we could say something like this, like let parts be this empty array, and then something like for let I be assigned the value of 0, I is less than input string dot length, I plus plus, whoops, I used an L instead of a semicolon. They're neighbors on the keyboard, so these things happen. And I guess what I want to do is just as we go from left to right, we want to load up this thing part. So we're going to let part be an empty string to begin with. And basically what we'll do is we'll say if, actually we'll let character be input string at I. Yeah, okay. We'll do this first and then we'll talk about improving it after. So if the character is a dot, then we're going to say parts.push part. Okay, so what are we doing here? Well, basically what we're saying is if you get to a dot, well then you're done. You've completed one of these numbers here. So push that in. That's the way it should be. Otherwise, if it's not, if it's something other than a dot, well then our part here, we have work to do with that. So we'll say part plus equals character. So we're going to put the character onto the end of the part here. And then after, so here we're pushing the part, let's clear it after that. So we'll say part is then going to be this thing. And then at the end of all this, we'll do part stop push, whatever part happens to be at that point. And keep in mind, that's going to work because part was defined out here. If we had done, like for example, out here, if we were trying to access character, we wouldn't have access because of this let over here. So the let is making it bound to the scope of this for loop. Same with like the I in here. We wouldn't be able to access it outside of the for loop. So that's block scoping like we've talked about before. Okay, so then part stop push part. So is this working first of all? Let's try returning parts and see what it comes up with. Great, so I mean that looks pretty good, right? We've got our 172, we've got our 316, we've got our 254, and we've got our 1 down here. Okay, so that's good, right? That's what we're looking for. Could it be better? Well, yeah, I think it probably could be. So first thing that sort of caught my attention when we were writing this out is this is the only time I'm actually using I. So I think it would be more efficient if I just said let character of input string. So this is one of these for of loops, which I believe is an ES6 thing. And it basically means, like, you know, if you don't have to use the index, probably don't use the index. Now, one time we did talk about a way we could use a for of loop and also get the index as well as the entry itself. But as it turns out, in order to do that, we have to use dot entries. And I just found out dot entries is actually not supported for Internet Explorer. So we probably shouldn't do that, I guess. Anyway, so okay, we're finding that this still works. Great. So is this the best way to do it, to separate the parts? Well, no, it isn't. There's actually a much more efficient way. So check this out. Remember, we've done stuff like this before where we take a string and we split it. And typically the way we would split it is just according to an empty string, delimited by empty strings. And the reason we do that is because we're trying to convert a string into an array. So this should give me an array of all the characters, just each individual character, which is not quite what I'm looking for. What I'd really like is not for it to split at every, well, technically it's an empty character, it's an empty string, but that would be like in between each character. I don't want it to split at those points. I want it to split just on the dots. So if I return this, what are we going to see? I mean, it should be splitting up the string in a similar kind of way, except now it's basically taking these dots as like the boundary points for each of the parts it's going to split up. So 172 is before the first dot, between the first and second dot we got 316, and you know, etc. That's how it's getting all these things. So basically this versus this. I think we're going to use the dot split here. I think it's just going to be a much more efficient way to do this. So we can just take this thing right here, cut that out. Might as well delete that. And I'll just put this right in here. So that alleviates the need for us to even go through any of that stuff. So that's nice. We've got our parts, and that was nice and easy, nice and brief. It's saying a lot with very little, so that's nice. Okay, so now we want to check that they're exactly 4 parts. So we'll just say if parts.length is, well, just not equal to 4. If it's anything other than 4, then we're just going to return false, because we know it couldn't be true. So that part's not too bad. And let's actually just say at the end here, let's return true, and we'll see how many we're catching with just that. We'll see if there are any that, yeah, okay, so 4 of them end up being right with just that test there. Okay, so now we want to check that each part is between 0 and 255. Okay, so let's try this. We'll say something like for, oh, forgot the let part of parts. And for each part, we'll say if it's outside the range, I guess, we'll return false, just like we had with the other one. So basically, if part is less than 0, or if 255 is less than part. Well, under either of those circumstances, we're going to return false, because that means part is outside the range of what we're looking for. And then if that doesn't happen at any point, if there are none of them that are outside the range, well, then we're going to return true under that circumstance. So let's run the tests on that. We'll see if that works. Okay, so 7 out of 11. That's better than 4, but it's not perfect. It's not great. Okay, so we've got a few of them right. This one is saying true. Yeah, that works. This one is saying false. It didn't work. This is the 316 was outside the range we were looking for. Okay, what about this one? This one's saying true. But that's kind of strange because the first thing is just an empty string. So it's saying the empty string is not less than 0 and it's not greater than 255. So I think we're going to have to add something else to this. Maybe we'll put in like a little test to see if this thing is actually a number. So we can say something like if. And other languages have things we can do like is numeric, right? That sort of thing. But we don't have that in JavaScript. We do have similar things. We could say something like type of part equals number. We could do something like that. But even that is going to be limited. I mean, actually, this isn't going to work at all because the problem is that part itself is a string. I mean, all of these numbers are being represented as strings right now. So basically, we want to compare it to a number, or we want to convert it to a number. So we could do something like this. We could say let num be assigned the value of parse int part. Okay, and then instead of part here, we're looking at num. Okay, so first of all, we'll see if that makes any difference here. And no, not at all. It's still 7 tests, and it's still this test 3 that's giving us some difficulty here. So, okay, let's do a console log of num. Let's see what it's actually coming up with, because that might help us sort of diagnose the issue. And okay, so none. There we go. Not a number. And something really strange is this. We saw this yesterday, but I want to show it again. So type of num. Now we've basically cast it to be an integer. We're saying it's going to be an integer. And yet when we say well, first of all, we find that num is none, which stands for not a number. And yet the type of that thing is number, bizarrely enough. So maybe we won't use type of. Instead, we're going to use number dot, I think it was is integer. I'm pretty sure that's what we used last time. So let's see if that actually works. There we go. So that's better. That's telling us no, none is not an integer. Okay, so basically we can use this as a test. We can sort of say if number dot is integer, or more accurately, what we want to say is if it's not an integer, then under that circumstance, turn false. And if it's not an integer, it's not going to work. It's got to be an integer. Okay, so let's try running that and we'll see if it works out any of the issues. Okay, great. So, wow, 10 out of 11. That's a lot better. Let's look at test 3 here. Okay, so that's returning false. It's as expected for the reasons we saw. Basically, just the non is not an integer. But now this is giving us an issue. So why is this one giving us an issue? Let's take a look. Console.log num. We'll get the console back in there and we'll see what it's coming up with. So look at this. Isn't that interesting? So it's saying we've got all these 4 parts. We've got 1, 1, 1, 1a. But the 1a, when we do this parse int on it, it's giving us just the 1. It's basically just getting rid of the a and just keeping the 1. So maybe we'll have to check something here. I mean, we could say something like, all right, let's do this. So let's compare length of num to length of part. Okay, so for part, that's going to be fairly simple. You know, we're just going to do part.length. And for num, it's going to be not quite as simple because Well, okay, we could do something like num.toString.length. And in fact, let's see if that works. So if this is not the same as this, if they don't have the same length, then under that circumstance, we want to return false. So let's see if that works. Okay, that's working. It's getting through all the tests. It's getting a little bit messy up here, so I think I want to clean this up a little bit. Okay, so compare length of num to length of part. Let's make some new variables. So we'll say part length is part.length. Maybe that's overkill. Who cares? Num length is going to be, well, the way we have it right now is num.toString.length. But I have to say, it does seem kind of silly to me that we're converting the part into a number, and then we're converting that number into a string just to measure its length. It kind of feels like we're just juggling it around kind of back and forth here, which is not great. That's sort of not what we want to be doing. So instead, well, let me just get this in here. Part length is not equal to num length. Then we'll return false. Okay, so how can we do this differently? Well, logarithms. That's what we found earlier, that we were able to use a logarithm for this. And I think it was something like math.floor of math.log10 of num plus 1. I'm pretty sure that's what we used. You can look at my previous video on logarithms if you need sort of a refresher on that. And what are we finding here? Okay, so now test 5 is going wrong. Why is test 5 going wrong? Okay, so it's doing a console log of num. It's only making it to the first one where it finds that this is 0. And what's the issue with this? So math.log10. Oh, yeah. Okay. So this is another exception we're going to have to deal with. I mean, basically, you can't take the logarithm of 0. You can't take the log of 0. Okay, why can't you take the log of 0? Because basically, the way log works, just as a quick refresher, we're doing log base 10 of some number, which I'm just going to use n here, just so we can use a one character variable. And we'll say that, I'll put an x here. This was the unknown exponent. This was the part where we were putting in a 0, right? So we were saying, yeah, you can't take log of 0. The reason is because this is logarithmic form, but if we wanted to put it into exponential form, we're basically saying 10 to the power of x is equal to 0. But the question is, 10 to the power of what is going to give us 0? And, well, let's try to find out. So we could say, well, 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1,000. But we're probably noticing that this isn't actually bringing us towards this value of 0. It's getting us further away. So maybe we'll go in the other direction and we find that 10 to the power of 0. Well, in case you don't know what 10 to the power of 0 is, basically we can just take a look at the pattern here. Notice when we're going this way, we're basically multiplying by 10 each time, multiplying by 10 each time. That's meant to be a 0. There we go. Which means that if we were to look at it the other way, going in this direction, we'd be dividing by 10 each time, dividing by 10 each time. And we'll keep that pattern going and we'll divide by 10. So what's 10 divided by 10? Well, it's 1. Okay, and then we'll keep the pattern going. So we'll say 10 to the power of negative 1 is going to be 1 divided by 10, which is 0.1. And then 10 to the power of negative 2 is going to be 0.1 divided by 10, which is going to be 0.01. We could keep this going, but the problem is 0.1, 0.01, 0.0001. As long as we have a 1 at the end here, as long as there's some kind of digit at the end that's not 0, then this thing has some value. It's not ever going to actually become 0. If we wanted to put it another way, we could say, well, actually, you know what? Here's another tool that we can use. So desmos.com/calculator. This is a very good resource for anything math related. So we'll just take a look at our graph here. We'll just say f of x is equal to 10 to the power of x. So this is our exponential function. And what we find is, yeah, it kind of looks like it's reaching 0 over here on this end. But if we zoom right in, we find like even where it looks like it's making contact, there's actually a sizable gap there. So that's our exponential function. If we wanted to find our logarithmic function, we'd basically just reflect this in the line y equals x. And so treat this as your mirror, the mirror image of this. Well, it's going to be, let's call it g of x, and it's going to be log base 10 of x, and it's going to look like that. So we've got the Christmas colors happening here, and you know what, let's put it on projector mode so we can see this a little better. All right, so basically the idea is that these are mirror images of each other, and just as this one had a horizontal asymptote at y equals 0, it was never actually making contact with the x-axis, even though it looks like it's coming very, very close, but that's just because, you know, these numbers are like 0.000000001. The point is, they're not 0. And it took a lot of zooming to figure that out, but they're not 0. It's never actually hitting the x-axis. So since this one is a reflection in the line y equals x, that means this one will never hit the y-axis. In other words, if we try to put in 0 for g here, so g, like we could put in other stuff, we could say g at 100, that's going to be 2. G at 10,000, that's going to be 4. G at 1, that's going to be 0. G at 0.00001, that's going to be -5. But what about g at 0? No, undefined. You can't do it. Okay, so hopefully that's convincing. Let's go back to this one. That's why it's having an issue with this one. And, you know, there are ways we could deal with this. But, well, we could say something like this. We could say num. And so then if num is non-zero, it'll give us this thing. If num is 0, then we'll just say the length is 1. So that's probably the easiest fix there. I mean, there are other ways we could do that. We could do sort of a more math-based solution, but I think this will work. Oh, hey, Ange, how's it going? Okay, yeah, so that's working for us. Let's get rid of the console log, and then I guess, can we do anything else? Oh, yeah, we can. So check this out. Notice how we have if this, return false. If this, return false. If this, return false. So basically what we're trying to say is if this is the case, return false. Or if this thing is the case, return false. Or if that last thing is the case, return false. So we'll put all of those together, and we'll run the test on that one. And it should work the same way. There we go. Okay, let's just maybe clean this up a little bit. When you do an enter, it's basically going to put the next line at the same horizontal position as where your last parenthesis or bracket was open. So it's because I had the open bracket over here that all of these ended up right at that space. I think that's just a Sublime Text thing. Anyway, let's run the test just to make sure I didn't break anything with that. Great. So let's submit this thing now, and we'll see how it does. We'll see if it passes all the hidden tests or not. There may be some part. Oh, no. Okay, so it did pass all the hidden tests. Great. All right, so that's nice. We'll close this, and I want to try to think about this in another way. So the way we're looking at it right now is we're looking at it very numerically. You know, we're thinking of these things as numbers. But technically, they're not really numbers. I mean, these things are strings containing digits, right? Containing numerical looking characters. But the thing is, they are strings. And we're trying to verify, or we're trying to check some property of these strings. We want to see if it holds a particular structure. Now, because of that, this might be a good situation for us to use regular expressions, because that's basically what they're for. You know, if we're dealing with strings, if we're trying to figure out some kind of property about a string, regular expressions. Okay, so let's try doing this with regular expressions. So before we go any further, I'm going to comment this out as we sometimes do. But then, whoops, yeah, there we go. Then I'm going to resurrect it. So I'm going to grab all the stuff that we're basically getting rid of, and I'm going to put it back in here because I want to see if we can sort of adapt this, I guess. So first of all, okay. I want to try to clean this stuff up over here. So for each of these parts, we want to check, is it a number, right? So let's deal with that first. So we want our regular expression. Our regular expression is going to look like something in between these. And then we're going to do a dot test on part. Okay. And what's going to be in the regular expression? Well, you know, maybe we'll have something like this, 0 to 9. So you remember doing these regular expressions before? We basically had this kind of thing. In fact, you know what? Here, let's go over here. Let's go to regexp101.com and we'll work it out over here maybe, and then we'll sort of compare afterwards. So let's just say 192 to begin with. And we want to check, okay, so if our regexp is this, 0 to 9, it's going to match any single character within this range. So anything from 0 to 9. So it matches the 1, it matches the 9, it matches the 2. Okay, what if I wanted it like, you know, 0 to 5, let's say. So now it's only matching the 1 and the 2, not the 9. Okay, and you know what? We could do it like this. We could say, yeah, 0 to 9, or we could do it more efficiently and just say /d for digit. And that way it's just going to match anything from 0 to 9. See, it's basically the same thing. One fewer, or I guess like, yeah, 3 fewer characters. So that's nice. It's a little more efficient. Now we want to basically say that we have 3 of these things, right? We want it to be something like this. 3 of those, 192. Perfect. Okay. But what if we also wanted it to match like something that was just like, I don't know, 68, or something that was just like 1 or 0. Okay, so then instead of 3, maybe we'll say like 2 or 3, right? And then that way it's going to match 3 digits, 2 digits, but still not these ones. So maybe I'll make it 1, 2, or 3. Okay, so this is a problem here. This sort of represents a misunderstanding of how this works. It's not that I'm trying to put a list of all the possibilities. It's that I'm basically trying to state a range of possibilities. So 1, 3 means it can have between 1 and 3 of these things. Okay, so that's worth noting. And notice now it's matching each of these things. So maybe we'll use that as our regular expression. Let's try that. So instead of this, we'll say \d, open brace, 1, 3, close brace. I don't think I want the space in there. All right, and we want to test that with part. Let's wrap that in an if. So if this, and actually what we're trying to say is if it doesn't match that. So we'll say if not that, then return false. Okay, so let's see how this differs in performance. All right, so definitely not as good. It's only passing about half the tests here. So it's passing something that looks like that. It's not passing something that looks like that. What else is it not passing? Okay, this thing over here, this actually surprises me. Oh, you know what? I think I get it. So 1a, here's the issue. If I were to put a 1a into this, it's matching the 1 part of it. So it's saying, yeah, I matched part of it. And the fact that it's not matching the whole thing, well, it doesn't see that as a problem. So we can build in some more stuff into our regular expression. Let's say that we want to say that this, like it starts and ends with the number. So it just has these 1 to 3 numerical characters, but before that starts, it's the beginning of the string. And then at the end of that, it's the end of the string. Okay. So basically the idea is that these are key characters you can use in regular expression. So this one says this is going to be the start, that's going to be the end. Okay, so if now we change that to like 1, 2, 3, now it works. But if I put a space, no, that's not going to work. Or if I put it before, not going to work. It has to be right at the start of the string. Or if we had like, you know, an extra character, too many. Whereas if it was something like this or this or this, that's fine. Okay, so we want to put in the caret at the beginning to mean the start of the string, and the money sign at the end, or the currency symbol at the end, to represent the end of the string. Okay, so let's get that inside the regular expression. So it's got to be in between the forward slashes there. And there we go. So that should pass test 4 now. That's what we're hoping. So it might bring us up to 7 out of 11 tests. Let's see. Oh, 8 out of 11. more than I was expecting. So test 4 is now passing. That's great. But it's still having an issue with this one, and it's having an issue with this one, and it's also having an issue with this one. Now, those three all have something in common. In each of those cases, there was a number that was outside the range. So this one was 256, this one also had a 256, and this one had a 316. So we're not actually checking if the number is like an okay number. You know, we're not actually checking to see if the number is outside the bounds of what we're looking for here. So, okay, let's deal with that then. So let's think about what kinds of numbers we could have. So we could have a number like, let's say a 192. Nothing wrong with that. We could have something like a 255, but we wouldn't want a 256. Okay, so let's start there. If, and actually, you know what? I'm just going to clear this whole thing for now. We're going to restart. So, okay, it could be something that starts with a 2. Now, if it starts with a 2, then the maximum number it could have after that is a 5. Okay, so if it starts with a 2 and then a 5, then the thing after that can only be 0, 1, 2, 3, 4, or 5. So we're going to say 0 to 5. Okay, so a 2, a 5, and then something between 0 and 5. So this is still not matching, but if it was 255, no problem. If it was 252, no problem. 251, 250, all of those are matching. Okay, but then the problem is something like this is now not matching. All right, so we've dealt with part of it. And also like 216, for example, also not matching. So if it's not that, and we'll just put in this little or here, maybe it still starts with a 2, but maybe the next digit is not the 5. So what else could it be? I guess 0 to 4. So we'll put in 0 to 4 here. And then the last digit, it could be anything, right? If it's like 249, that would be fine. So let's just put in a digit. All right, full match, 216, there we go. And 249, yeah, that works, no problem. All right, so those are two possibilities. Those are, we're kind of cutting away at the largest kinds of numbers that we could see. So now, let's say 199. Let's say we wanted to get 199. So it maybe starts with a 1 and then has any kind of digit and then any kind of digit, right? I mean, it could be 199, it could be 100, and it could be anything in between, and this thing would match it. So 1 followed by any 2 digits. What else could it be? It could be something like 98. So that would just be 2 of any digit, 2 of any digit, or 1 of any digit. Okay, so now this is a lot more robust. It's covering, I think, all the cases we're looking for and not the cases that we're not looking for. Great. Okay, so then this part over here, the only thing about this is I'm kind of thinking, well, maybe we could clean this up a little bit. So like here we're saying 2 characters or just 1 character. So really, I guess what we're trying to say is this character here, the first one, like the tens column, so to speak, optional. So we'll put in a question mark, and that way we don't need to worry about that anymore. We could say, 192.168.0.1. It's matching all of those, and maybe I'll make this 10. Okay, great. So it's matching 2 digits, it's matching 1 digit, it's matching 3 digits. And then also, I mean, look, this is basically saying that like this is a 2 or 1 digit number. This is a 2-digit number with a 1 in front of it. Maybe we could just say, hey, make the 1 optional and make that one optional as well. And then we can cut away that last bit and it still works. So our regular expression is getting a little more efficient here. It's getting a little more efficient. Okay, so then let's take this and let's put that inside. So that's got to be right in there. Great. Okay, so let's try that. All right, what happened here? So this one still made it to true. Now that's kind of strange. 316 I thought would be failing here. So let's see what happened. Let's console log the part. And yeah, okay, so 316, I thought that would fail. Let's go back over here. Why is 316 working? Oh, okay, maybe because it's matching like the 31 over there or something like that. So, okay, let's put these in parents. And now the issue with this is it's kind of like it's got a capture group here. I don't really want that. So I want to make this a non-capturing set of parentheses. So the way we do that, it's going to look a little weird. We're going to put a question mark and then a colon. So it looks almost like some kind of weird emoticon from back in the AOL days. But the point is, this is a non-capturing group. So anything between the parentheses here, it's not gonna, we're not gonna capture that. We're not gonna have to use that like we've done in some of the other challenges. So there we go. Okay, now with the start of the string and end of the string, and within this non-capturing group, we have all these possibilities. Now you might be asking, well, why did you need the non-capturing group here? Why don't you just put the caret right in front of the 2 and then the money sign right after the /d at the end there? Well, the reason is because then it would think I'm saying, well, it could be the start of the string followed by 2, followed by 5, followed by anything from 0 to 5, or it could be 2 and then something else. Like it would only put the caret on this first one. So I want the caret to be applicable to any of these. Basically, start of the string and then either this, or this, and then the end of the string. That's what we're saying. Okay, so let's try that now. So we'll bring that over here, and we'll keep the we'll keep the forward slashes as well. We'll just paste that in, and we'll see if this is going to work now. Great. Wow. Okay, so that works, no problem. And you can see just how much we're able to cut down our code here. I mean, this part here is a lot less than all this, right? So that's kind of nice. In some ways, it's kind of not nice though, because all of this was, I would say, relatively easy to follow. Maybe not when we get into like this part over here, but the main thing is that we can sort of see what we're trying to do with all this stuff. Whereas with the regular expressions, I mean, regular expressions, when you look at something like this, it looks like a headache, basically, like trying to unpack all this stuff is just very painful because it's essentially a program that's being written with as few characters as possible. It's like a code golfing challenge. So yeah, it has its disadvantages. It's not exactly clear to the reader what we're talking about over here. So yeah, that is going to be a disadvantage for regular expressions. In terms of runtime, I think it's better, but I wouldn't be able to tell you for sure. We'd have to do some kind of JS perf on that, or one of those other options out there. The point is, for this is good. It's getting a lot better, but could it be better than this? Yeah, I think it could be. So basically, the idea is that we want to have something like 192.168.1.0, let's say. And okay, now this thing is not matching that. That's because we've got the start of the string here and the end of the string over here. Okay, so now if it doesn't have to have those things, now it's going to match each of those. But now let's say I also want it to have a dot at the end. Okay, so now it's matching this first one, it's matching the second one, it's matching the third one, it's not matching this one, which is kind of a problem, right? We want this, like basically the idea of what I'm doing here is I want to use the regexp itself to basically say like, we've got 4 of these things, like all this stuff here, all of this, I'll do another non-capturing group. So like all of this, including the dot at the end. And also, okay, this is sloppy of me, but I should have put a backslash in front of that dot so that it's actually matching the dot character. Because otherwise, like, this could be the letter A or something. And it's like, yeah, it matches. Remember, dot in regular expression stands for wild card. So watch out for that. There we go. That's more what we want. We want literally a dot. Okay, great. So then what else? Basically, what we want to say is there are going to be 4 of these things. But currently that's not working because there are only 3 of these things. but we want it to be like this. So, okay, we could say there are going to be 3 of these, and then there's going to be one at the end that doesn't have that, right? So something like this. Okay, and now that should match. So let's try this. And actually, okay, let's not forget, we want to put the caret at the start, and we want to put the currency symbol at the end. Okay, now let's take this whole big thing, and let's just say, we won't worry about the split. We won't worry about the length is 4. Let's just say return regular expression dot test input string. Let's try that. Wow, look at that. So this, definitely fewer lines than all this stuff down here. Is it as easy to follow? I don't think so. And part of the reason for that is it's kind of messy. We have like this, 3 of these, and then the almost exact same thing right after it, and then the end of the string. It really would be a lot nicer if we could just say 4 of these things. But the problem is, the reason we weren't able to do that over here, and I'll just show you again, it was this. If we put 4, now it's not matching. Unless we put a dot at the end of this. Now it's matching the whole thing. So this is kind of sneaky. I don't know if this would be considered proper or maybe a little hacky, but that's what I'm going to do. I'm going to say, put a dot on the end of that thing. And then let's try running that. And we find that it works. All we needed to do is put a dot on the end, and now we do have 4 identical groups. So it's kind of sneaky. Maybe it's kind of like cheating, putting the dot in at the end there, but I guess whatever works, right? So does it work? That's the question. Is it going to pass all the hidden tests? Let's find out. Oh, it sure does. Okay, great. So that feels good. Feels great, actually. I love the idea of getting a working algorithm and then just crunching it right down to a one-liner like that. That feels great. We really feel like we've conquered something here. So the only problem, like I said before, is that this thing, despite being extremely efficient and really getting a lot done, it's not really going to be human readable to someone who's not already very familiar with regular expressions. And that's kind of a common story when it comes to regular expressions, that well, okay, there's like that anecdote, right? They say like, oh, I had a problem, so I used regular expressions, and now I have 2 problems. So that maybe gives you an idea of how a lot of programmers feel about these things. Good question, Ange, the computation time. That's not something I'm really sure about. I know that like regular expressions can do stuff like recursion. There is such a thing as regular expression recursion. And so I have to imagine something like that would depend on the size of its inputs. But for something like this, I think it would probably be big O of 1, because we're specifically looking for 4 of these things. It's not like the size of this is going to depend upon the inputs or anything like that. Because I could see some regular expressions depending, like especially if they had like stars or plus symbols, things that say like this can repeat an arbitrarily large number of times. For something like that, I think it might depend, because a larger input would basically make it keep going for longer. But for something like this, if it sees that there are more than 3 characters in between the dots, then it's just going to know that it doesn't match. So I think that this would be big O of 1, but I could be wrong about that. And I think for what it's worth, that this algorithm down here, our first one, I think that's okay, what I'd say is it's probably very close to being big O of 1. Like technically we could say that this first thing here where we do the dot split would be dependent upon the size of the inputs, because what if they gave us something that was like just like a string with 1 billion dots in it? Then this would take some time to maybe execute, but then right as soon as it checks this thing, it's going to just be done. It's not going to worry about any of this stuff down here. So I think this would more or less be a constant time algorithm, especially when you consider that the input string has a maximum of 15 characters. Well, with that fact in mind, it basically means we don't really need to worry about computation time here. But, time complexity is definitely something that's good to keep in mind. So very nice question. Thanks for asking. I think we're probably done here. We passed all the tests. I don't think we can make this any shorter. So yeah, let's move on from there. Nice job, everyone.